So 2, 3, second half of it, we're actually going to have to read and put things in to practice, okay? So we talked about this, we started it on Thursday. We have 3 triangles, but how many right triangles do we have? 2. We have the small one and the large one. We cannot do any math with this non-right triangle here. Not yet. I haven't taught you anything. Oh, except we could find angles if I had 2 of them, right? But you can't use Pythagorean theorem on it. You can't use sine, cosine, tangent. They're not right triangles, okay? So what we did is we had the smaller triangle, and we said if I have the opposite and adjacent, so we did tangent of 54 equals h over x. Now the reason we want x, yes, and both of these triangles, the large and the small, both involve h and x, don't they? So those are the 2 sides we want to be using. Plus, those are the only sides we have any information on, correct? So then the large, we have the tangent of h over 32 plus x, and you guys did that right away, all on your own. That was really good. So if we want to solve ultimately for x, we have 2 equations with 2 variables, h and x, correct? We don't want h, we want what? X. Rule of thumb for myself is I solve for the variable I don't want in the end. Because if both equations equal h, then both equations equal what? Each other? The transitive property? There are some people that will go, well, which one's it easier to solve for, h or x? Oh, so I'm going to solve for h, or I'm going to solve for x, but then they have to plug it back in. And what do? Sometimes forget to plug it back in, right? So we started by solving for h over here. So we had multiplied by x, yes? Now, we have h equals x tangent of 54. We used substitution and just replaced this h with what is our new h? X tangent of 54. Could we have multiplied this over and set them equal to each other? You want me to show you what that looks like? Okay, so if I want to use the transitive property, I would multiply over by the denominator, and I would have h equals 32 plus x tangent of 38. So if they both equal h, then they equal what? Each other? So I'm going to put this out there to you. Do you want to solve this one for x, this one right here? Or do you want to put these 2 equal to each other and solve for x?
I'd rather do x tangent of 54 divided by 32 plus x.
You rather do this? Anybody else? Okay. So the substitution is where you'd go. Now the first step with this, we would multiply over by what?
Denominator.
The denominator. Right? Because it's in the denominator, we want it out of the denominator, so it would be 32x times the tangent of 38, correct? Mm-hmm. Watch when I move my hand. Is that what we would have it equal to? See that? And the top would be what? So, either way, are you going to end up at the same point is what I'm getting at.
Yeah.
Yes. Okay, does everyone know how we went from this step to this step?
Yeah.
Okay, so what are we solving for? X. So we've got an x over here and we have an x over here. And so we need to move x's all on one side, correct? Mm-hmm. But I can't do that yet because of why? The quantity, right? So what do I need to do before I can move that x? I need to distribute. So I have x tangent of 54 equals 32 tangent of 38 plus x tangent of 38. Now, I will tell you, if you looked in the textbook, they would put tangent of 38 in their calculator and tangent of 54 in their calculator and put those in. This is my problem with that. If I do that, I've rounded here, and then when I'm going to do it again, I'm going to round again. So I've tripled my rounding error, correct? Second thing is when I put this in, I'm going to have like a 4 decimal number that I have to carry around and not screw up. Is it going to be easier to carry around tangent of 38? Yes. Because you're not going to have like 13.6843 that you have to keep writing over and over and over. Okay, so we're here. Remember, we're thinking basic algebra. So when we have basic algebra, we need to do what with our x's? I solve for x, right?
Mm-hmm.
But so what do I need to get them all on one side? So what are you going to do? How?
Minus x tangent of 38.
We're going to minus x tangent of 38 on both sides. So x tangent of 54 minus x tangent of 38 equals 32 tangent of 38. I didn't say these were fast, did I? But are we basically doing the same steps we did on the problem before it? Yeah. Okay, so now I have 2 x's and I want 1 x, so what do I do over here? Not mine. I can't because this is tangent 38 and tangent 54. They're not exactly the same.
Divide over. Both.
Well, divide, yes, but factor. Isn't division factoring? Factoring division? Can I factor an x out of these two?
Yeah.
Because we are going to have to divide over, but not till we can factor. Because we went from 1, we're going to go from 2 to how many? 2 x's to how many x's? I didn't say that. 1. Now, should I be crowding my work? Heck no. I got scratch paper over there if you guys want to use it rather than your lines. Hey, everyone following what's going on? Am I going too fast for anyone? Okay, why did we do from here to here? Why did we do it?
Separate the x.
Yeah, to get that x all by itself.
Quantity over.
Yep. So now I just divide by that whole quantity. And I don't rewrite it, I just write my answer. So 32 tangent of 38 divided by, put your parentheses, tangent of 54 minus tangent of, does anyone know why I made a point to say put your parentheses?
So you noted about that whole thing. You can't.
I can see it. I can see what you're trying to say. Reduce, right?
Yeah.
Because how many of you would have said, oh, let me just take out that tangent of 38? Right? So now we're going to put this all in our calculator at one time. Good rule of thumb is put parentheses around your numerator, parentheses around your denominator. Even if you don't have to, if you do it every time, you'll do it when you need it. So 32 tangent of 38, double parenthesis, divided by tangent of 54 minus tangent of 38. I got approximately 42.0. And did we have units on this one?
No.
Feet. I didn't write them on there, but they were feet. I don't know. It's a long time ago. Thursday was a long time ago. Did you guys get that?
Yes.
Okay. So let's talk about what we did. What was the process of this? When I had 2 unknowns, how many equations do I have to solve them?
2.
2. If I have two unknowns, I have to have two equations. Okay? Why did we choose tangent?
Because it's over
Because we opposite and
adjacent.
adjacent. Okay?
They didn't get the right answer.
You didn't get the right answer?
No.
Did you put it in exactly like that? Parenthesis 32 tangent of 38, two parentheses, divided by, if you go up and hit enter, it will let you move through it.
I didn't put two parentheses over the top one.
Okay, so what you did was, yeah, I don't even know.
Parentheses on top.
Well, the top one honestly doesn't have to because of the fact that it's multiplication. But Emma, if there was addition, subtraction there, you have to. So that's why I said just get in a, I just think it's a good rule of thumb. Every time I do it, I do top in parentheses, bottom in parentheses so I don't forget. Did you go add it and it fix? Did you add it?
Is your thing on degrees?
Oh, you're on radians. I can guarantee it. Because you just downloaded it. I didn't realize you were on your phone.
Mine started with radius. What is it?
Mode.
Mode.
And then it should be the
Radius. Alright. Okay.
Well, there's a calculator gone over there, so I thought you had it.
Yeah, I brought it back. Yeah, that's right now. Calculator gone?
Yeah, there's two of them gone, and I have one.
I was like, you have one.
I know, but there's two gone. Do you have one?
What's the one behind it?
Huh?
On the front. Is that one of the ones in front?
That's one of the. But they were all there a minute ago.
Yeah, I told you there was one missing.
No, they were all there. When he put that one back, they were all there.
The ghost didn't think it.
Where? Which one's missing?
The back one and the second one. Because I took the back one. It's whatever. Okay, so
You little.
how are we going to remember this process? Guys, how are you going to remember this process? Because it's going to happen through the whole book. If you're going to have basically the same picture pop up over and over and over. Or we have another picture that comes, that happens a lot, like this. Because we have a right triangle here and a right triangle there.
Oh.
So this is going to happen over and over and over again. So did we understand what happened? Because if you learn this, it'll be easy. If we struggle, if we're not learning it or don't understand what happened, it's impossible. Because everything is hard until you know how to do it, and then it's easy. Right? And I never promised you that it would be fast, but do you understand what's going on is what my question is. Okay. So now we have our Ferris wheel. So what would a crude picture of a Ferris wheel look like?
Circle.
Circle.
Blue.
Well, we'd go from like the center to the ground, correct? Okay. Now, some people will draw their Ferris wheel like this, and they'll put their center, and then they do this, because that's actually what it looks like that supports it, correct? But then they have this information here, and then they have two extra lines that are doing what with their brain? Are they confusing your brain? Yep, so don't put them in there. Okay. So there's our crude Ferris wheel. And I will tell you, when I give you a picture, they'll be there. Just because I can't draw a Ferris wheel without them. If you look in the book, they're there. But then they take them away.
What?
The side supports. Okay, so we have this. In the introduction of this section, we gave some facts associated with the first Ferris wheel. Image 5. Is a simplified model of the Ferris wheel. If theta is the central angle formed by the rider moving from position P sub 0 to P sub 1, find the rider's height above the ground h at 45 degrees. So I'm going to fill some information in here that you don't have yet. And that is a horrible circle. Sorry. I can't do it.
That one was a lot better than mine.
Yeah, but that's a lot better than that. Okay. So, P sub 0 is here. Why is this P sub 0 right down at the bottom? P stands for position. 0 stands for 0 time. Why is it there?
Because it's
Is that where you get on a Ferris wheel? Yeah. Okay. And then P sub 1 is some random point around this circle. I am going to tell you, no matter what angle I give you, this is what your picture should look like. Because it just will make it easier. It just will. And theta is here. Now, again, in the textbook, if you see this, there are these side supports right here. Do I need this information?
No.
No, it's just going to mess my brain up. So when you draw it, don't put them.
I said it was 45 degrees.
It did say theta was 45. I'm just giving you a general picture. This picture can be used on every single one of these problems. Okay, so, and I want the height, so that would be, right here would be the height, wouldn't it? Bless you. That would be the height. And here is the ground. So the information they told us about this Ferris wheel at the beginning was that the diameter of the wheel is 250 feet. There's 36 cars. And from the ground to the top, it is 264 feet. 600 feet would be horrible. Okay. I do think one of the problems says use the information given to you. It's on the very first page of this section, so you just have to scroll back or use this problem. Okay, so it wants H. So what are the things we know and are able to use? Right triangles, correct? What other shape should we be able to deal with?
Circles.
Circles, one other one.
Squares.
Rectangles. Can we say rectangles instead of squares? Okay, so circles, triangles, rectangles, we should be able to deal with very proficiently, yes? So in this picture, because I have this polygon right here, don't I? It's quadrilateral. Can I make those circles, triangles, rectangles? If I take this straight over, I've made what?
Triangle. And
What kind of a triangle?
right.
A right triangle. Little pictures don't work very well, do they? Okay, I have a right triangle and then I have a rectangle, don't I? Like I didn't go very straight. There we go. So I've got some numbers here. How can that help me out? My diameter is 250 feet. From the ground to the top is 264 feet.
Well, can't we figure out the height?
We could do the radius.
The radius, right? So from here to here is what? 125, because radius would equal 250 divided by 2.
Yeah.
And I'm writing more than what you probably would normally. Actually, I'm not going to write it here because that's cut up. Where am I going to write it? Again, why did I write it here and not here?
It's the same thing.
It's the same thing, and is this cut in pieces?
Yeah.
Yeah. Okay. What else could I get from that information? How?
264
Well, 264 is just from here to here.
What are we trying to find?
We're trying to find the height of the rider, because I'm right here.
Okay.
And this height here, doesn't that translate exactly over here?
Yeah.
Yeah. And all the information we have has to deal with over here. Yes? So what does this tell me? 264 and 250 is my diameter.
There's 14 feet
There's 14 feet where?
in between.
In between the bottom of the wheel and the ground, yes? So this is 14 feet. Okay, so that means we have how much of the height? Don't we have see how that 14 feet can go from here to here? So all we need to know is this much, and where can we find that? Can we find it over here?
Is it the radius?
Well, this is part of the radius, right? What part of the radius does it not include? The part in the what shape? In the triangle. Can we find that part of the triangle?
Yeah.
Because we have the angle, because we have theta is what?
45.
45, and we have the hypotenuse, so can we find this x?
Yeah.
So this piece right here we need is 125 minus x. Everyone see what happened?
Yeah.
So, we got to find x. So the height is going to equal 14 plus 125 minus x. Isn't that our plan? To add these two? So when I do these problems, I do all this work. I'm like, okay, this is what I have to do. So I have to find what to make this work? X. Can I find x?
Yeah.
Yeah. So I have theta, I want x, and I have the hypotenuse. So what function is that?
Cosine.
Cosine, because I have adjacent, I want adjacent, and I have the hypotenuse.
Yeah.
So the cosine of 45 degrees equals x over 125. So how am I going to solve for x? So x equals 125 cosine of 45. So I can put that in here, yes? So h equals 14 plus 125 minus 125 cosine of 45. Well, you know the cosine of 45 degrees, yes? Or should know it.
Um.
45, 90. So square root of 2, square root of 2, 2. So it's square root of 2 over 2.
Yeah.
Okay. So 125 minus 125 square root of 2 over 2. So without a calculator, there is your answer. On your test, there is your answer. If I don't give you a calculator. Got it? With a calculator, you just put it in the way it is. So 14 plus parentheses 125 minus 125 times the square root of 2 divided by 2. Or could I put 14 plus 125 minus 125 cosine of 45?
Yeah.
I better get the same answer either way, right? Did you get the height as approximately 50.6 feet?
Yeah.
Now, in your book today, in your assignment, you have, I don't know. They'll have like 61. I think you have 61, right? Yeah. So you have 61, and then they put A, B, C. So 120 degrees, 210 degrees, 315 degrees. What does that change? What's the only thing it changes in this problem once I do it once?
Degrees.
That angle. So if I do that all with theta, just with theta, can I plug in my 125, my 210, whatever?
Yeah.
Okay, so